are actually quite a lot of properties of logarithms to be learned. For example, okay, there are some special cases of logarithms. So one special case is this one. That is the logarithm of a to the power x with base a is equal to x. Because we know that a to the power x is equal to a to the power x. So this equation has to be true. And the second one is something like this. Something in reverse. That is a to the power the logarithm of x with base a is also equal to x. Because this logarithm means what number should I raise to a so that I can get x. And now I actually raise this power to a. So actually I should be able to get back x. Quite complicated, but the concept is quite simple in this case. Another special case is this one. That is the logarithm of 1 with base a is always 0. And of course here we assume this a to be positive and not equal to 1. That means 0 is not included as a base in this example. Okay, so when we take logarithm for 1, we will always get 0 because we know that a to the power 0 is 1. The logarithm of a with base a is always equal to 1 because we know that a to the power 1 is a. So after looking at some special cases, there are some general properties. The first property is like this. That is the logarithm of a product. That means the logarithm of xy with base a is actually same as the sum of the logarithms. And the second property is that the logarithm of a quotient, that means the logarithm of x over y, is same as the difference of logarithms. And then the third property is that the logarithm of power, that means the logarithm of x to the power k, is same as k times the logarithm of x with base a. And finally we have a so-called changing base formula. And here we know that the logarithm of x with base a can actually be rewritten as the logarithm of x with another base b over the logarithm with a with the base b here as well. So that means we can express the logarithm with a certain base in terms of other bases like this. And here are 8 important formulas to be remembered or understood in HKDSE. Now I want to show you why these 4 formulas are always true. So in order to prove this, first of all you need to consider something like this. First of all, we let a to the power n to be x. And we also let a to the power n to be y. So based on these 2 definitions of x and y, then we can express m as the logarithm of x with base a, and then n to be the logarithm of y with base a. And now let's take a look at this. If we would like to prove the first formula, then we can do something like this. Here we know that an plus n is equal to an times an by the index law here. And then a to the power m times a to the power n is same as x times y. And since we know that a to the power m plus n is equal to x times y, then by the definition of logarithms, we know that the power here, n plus n, can be expressed as the logarithm of xy with base a. And here, since we know that m is log x with base a and n is log y with base a, so here we should know that log x with base a plus log y with base a is equal to log xy with base a. And that's how we can prove the first formula. And if you would like to prove the second formula, then you can apply this index law. And we know that a to the power m over a to the power n is just x over y. So based on the definition of logarithms, we know that the power m minus n can be represented as the logarithm of x over y with base a. And since we know that m is log x and n is log y, then we can conclude that log x with base a minus log y with base a is log xy with base a. And that's how we can prove the second one. And in order to prove the third one, then we need to consider something like this. We start from a to the power m equals x, and then we can raise this to power k on both sides. And then we should know that a to the power kn is same as x to the power k. And now we should know that according to the definition of logarithms, then we can know that the power kn can be represented in terms of logarithms like this. That's log x to the power k with base a. But here we already know that m is log x with base a. So here we should know that k times m is log x with base a, and this one is same as log x to the power k with base a. And that's how we can prove the third one. And finally, for the last formula, we can consider something like this. First of all, we know that a to the power m is equal to x. And then we can actually take logarithms on both sides with base b. And then we will get logarithm of a to the power m with base b, which is same as logarithm of x with base b. But here, we have already proven the third formula, so we can use it. So when we take logarithm of an exponentiation, we can always take the power here as multiplication. So this one is same as m times the logarithm of a with base b. So this one is same as the logarithm of x with base b. And finally, you should know that m can be represented as log x with base b over log a with base b. But originally we know that m is just log x with base a. So from here we can conclude that log x with base a is equal to log x with base b over log a with base b. And that's how we can prove the last one.